electron configuration. Actually, we're going to talk a lot about electron configuration. I'm going to show you how this works. One of the ways I like to show students electron configuration is just a matter of how electrons fill into orbitals and energy levels and configurations for each element. So imagine you scooped out a handful of electrons and threw it at a sodium nucleus that had 11 protons and, let's see, 12 neutrons. So you have 23 masses there. You threw 11 electrons at it. You could tell after this lesson, you're going to be able to tell me how those electrons fill and in what order and what energy levels. It's awesome. All right, so let's establish something. First things first, there are four major parts of the periodic table, and the parts are this little groups 1 and 2. And by the way, helium actually is only here because its outer shell is full. So all of these guys have a full outer shell. Those are called the noble gases. So all of these, full outer shell, full outer shell, full outer shell, etc. Okay, so they have a full outer shell. All of these have 8, except for helium. It only has 2 electrons because it's only got 2 available. Only 2 will fit in the first energy level. So technically, I might talk about right here being helium, sort of. Helium's secondary spot. But helium doesn't really go there because it's not a group 2 it's not a group 2 element. So each of the groups 1, and we're going to talk about groups 1B, 1, 2, and then we're going to skip over the transition metals. Skip. And then we're going to jump right to 13, group 13, but we're just going to mark out that 1, and we'll say 3. Mark out the 1 and say this is 4. Mark out the 1 and say this is 5. Mark out the 1 and say this is 6. Mark out the 1 and this is 7. And we're going to mark out that 1. This is group 8. Mark out the 1. There we go. All right, so what that means is that's the number of electrons in their outermost shell, or the valence shell. Okay? So group 1 has 1, group 2 has 2, group 3 has 3. The metals in the middle, the transition metals, that's all of these, they have a various number of oxidation states and different numbers of electrons in their outermost shell. And so they can make different charged ions. So we're going to talk about them a little later. So for now, let's just imagine that we've got the first 2 rows, or the first 2 groups, are in the s orbital. So orbitals are S, P, D, and F. And then the number of electrons, orbitals, and electrons. The number of electrons maximum in the s orbital is 2. The number of electron maximum in the p orbital is 6. We'll get to all of this. The number of electrons in the d orbital maximum is 10, and F is 14. Now, if you look at it this way, the number of pairs is 1, 3, 5, and 7. Ooh. So these are the s orbitals, groups 1 and 2. This whole section over here, with the exception of helium, helium doesn't belong in this. This whole area across here, let me see if I can draw a semi-straight line. Ooh, maybe. All of this block over here is the p orbital. Then the transition metals from here over to here. This is the d orbital. And then these 2 rows down here make up the f orbital. Not to be confused with your potential grade in chemistry. Just kidding. Just kidding. Okay, so we have S, P, D, and F. Now what happens when we write an electron configuration? We always start right up here at hydrogen. Start here. Every time. Okay, so we're going to start here. And so hydrogen's electron configuration is 1, meaning the energy level, energy level 1. Then the orbital, s. Notice it's in the s orbital, s. And then how many electrons? So in this case, it's 1. 1, s1. Helium, which would be right here, but except that it's way over here on the noble gas side, it's still in the first energy level. So helium has a electron configuration of 1, meaning energy level 1, type of orbitals, s, and how many? 1, 2. So 1s2 is the helium electron configuration. Now, if we go on to lithium, we've got to start at, where did I say you always have to start? It says start here, always start here. So you got to work your way across the periodic table, left to right, and then down below until you get to the one you're looking for. So if I'm at lithium, lithium's electron configuration is 1s2, because that gets me all the way across the first row, right? Puts me at helium right here. Then 2 energy level. What type of orbital? 2s. And then how many electrons? So this is only 1 in the second energy level, s electrons. So 2s1. Then beryllium would be 1s2, 2s2. So to recap, we're going 1, first energy level all the way across, and then second energy level, and we're just getting across the s's. Okay, so now jump across the pond. Boron would be 1s2, 2s2, 2, second energy level still, p orbital, and how many electrons? 1 in the p orbital. So 2p1. Now here's where I want you to point it out. Or here's where I want to point something out. Right here is the atomic number. That's the number of protons. And if the element or atom, or however you want to call it, is neutral, it's also the number of electrons. So if you look here, boron should have 5 electrons because it's atomic number 5 protons. So there's 2 in the first energy level in the s orbital, 2 in the second energy in the s orbital for a total of 4, and then 1 in the p orbital of the second energy level. So 2 plus 2 is plus 1 is 5, which is exactly how many we should have. 5 electrons, 5 protons. Beautiful, if it's neutral. Now, what you're doing then is you're starting at the top, and you're taking steps across. So 1s2 gets me across to here. 2s2 gets me across to here, right here. Then 2p1 here. So if I want to go to carbon, carbon is start here, always start here, always start here. Always. 1s2 gets me across here. 2s2 gets me across here. 2p2. So carbon is 1s2, 2s2, 2p2. Now you see what's happening? 1s2, 2s2, 1s2, 2s2, 2p1, 1s2, 2s2, 2p2. This one, nitrogen, is 1s2, gets me across. Always start here. Always. 1s2 gets me all the way to here. 2s2 gets me to here. 2p2, 3 gets me to here. So then you just change this to 3. 1s2, 2s2, 2p3 for nitrogen. And then oxygen follows 1s2, 2s2, 2p4. Fluorine would follow then 1s2, 2s2, 2p5. And then neon. Neon is 1s2, 2s2, 2p6. Okay. Now, 1s2 got me across the top row. Perfect. 2s2, 2p6 got me across the second row. So this is first row, second row. Any ideas where we're going next? So if we're down here to sodium, let me erase some of this stuff. See if I can get a big eraser going. right, SP, D, and F, I'll leave those. Now we'll just erase these. I'll put a few more different elements in place. Okay, where do we always start? Always start at hydrogen. Always. Did I mention always? Because what I meant to say was always. Always start at hydrogen. Okay, so we're going to start at hydrogen again. Only now, instead of going across the top, we're already down here to sodium. This is where we're headed. Okay, we start here. So sodium has a electron configuration of 1s2, 2s2, 2p6, 3, right? Third energy level. What type? What orbital? S. How many? 1. 3s1. Let me undo that. That's just terrible looking. All right, let me try that again. All right, 3s1. Much better. Okay, so sodium is 1s2, 2s2, 2p6, 3s1. Guess what magnesium is? Magnesium is 1s2, 2s2, 2p6, 3s2. 3 s orbital. How many? 2. Then jump across, and then aluminum is 1s2, 2s2, 2p6, 3s2, 3p1. So all I got to do is follow the periodic table. This will be 1s2, 2s2, 2p6, 3s2, 3p2. This will be 1s2, 2s2, 2p6, 3s2, 3p3. This will be 1s2, 2s2, 2p6, 3s2, 3p4, etc., etc., etc. Argon, we're going to turn the corner already. Now let's look at calcium. Calcium right here. What's the electron configuration for calcium? Let me see if I can erase this circle around sodium without making too much of a mess. There we go. Okay. Always starting at the top. Always start here. Did I mention to always start here? Because I meant to. And if I didn't, what I meant to say was start here. Hydrogen, always. We're going left to right, top to bottom. So 1s2 gets me across the top row. 2s2 gets me across here. 2p6 gets me across here. 3s2 gets me across here. 3p6 gets me across here. So we're going to calcium, 4s1, 2. So calcium, just to recap, 1s2 across the top row, 2s2, 2p6, 3s2, 3p6. Then the last one is 4s1, 2. Now, here's where it gets weird. And I would strongly suggest that if you have how do we say this, periodic table available, you should probably get it out and start getting ready to write some stuff on it, because I'm going to show you some cool stuff that you're going to go, hey. And then maybe talk to your teacher and say, is it okay if I use my own periodic table? Because I made some notes, and that might be worth having when it comes to taking a quiz or a test. Okay, if your teacher says, hey, I'm cool with it, then your teacher's a little bit like me. But if not, I understand. Some of them say, no, not today, Junior. You're going to have to learn it yourself. So here's what happens. After the fourth energy level, 4s2, this energy level with the transition elements, the transition metals, drops down to the third energy level. This drops down to 4. This drops down to 5, and I'll talk about specifically which one. This drops down to 6. And this actually drops down not to 6, but to 4. And this actually drops down to 5. Now, what happens here is 4s2, 3d. How many do we say d can hold? 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it jumps back up to 4p. So this is 4p6, right, to get to krypton. And then this would be jumps up to 5, and this would jump up to 6, and this would jump up to 7. Okay, so that's the deal there. So let's look at krypton. Krypton. And where do you start? Always start here. Always start at hydrogen. Did I mention to start at hydrogen? Because you should. Okay, so krypton has a electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3p6, 4s2, 3d10, 3d10, and then 4p6. Now, some people would say, wait, all the 3s need to be put together, all the 4s need to be put together. What I'm showing you here is the order in which they fill. The order in which they fill is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. That's the order in which they fill. There's nothing wrong with moving this 3d10 right after the 3p6 and putting it here, and then putting your 4p6 after the 4s2. That's nothing wrong with that, because then it keeps all the energy levels together. Then you can really clearly see the highest energy level represents the valence electron, so you can tell what group it's in and all that sort of fun stuff. Okay? So that's that. Now, when you get down here, energy level 5 jumps across, so 5s2, then it would go 4d. Actually, you'd have to go 1s2, because where do you start? Up here. You always start up here. Always start here at hydrogen. Always start at hydrogen. Now, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, then drop down 4f14, and that gets me to here. These two are actually part of the d orbital. These actually go right up here. So this is 103 and this is 71. So then it goes 6s2, 4f14, 5d, right, starting with number 7, 5d10, then it would be 6p6, then it would be 7s2, and then drop down 5f14, and then 6d10 gets me to here, and then 7p6 to get me down to the OG. Hey, FYI, this is ptable.com. If you're not using ptable.com to learn chemistry, there's something wrong with you. Okay? You need to use ptable.com, and I promise, I'm not getting paid to tell you that. It's just really, really cool. So it's an easy site, and you can do all kinds of manipulative things with the periodic table and find out all kinds of cool stuff about each of the elements. But ptable.com has 118 as the OG. I mean, come on. Who's got an OG on their periodic table? Almost everybody, I hope. So here we go. That's how you get all the way to the bottom. Now, I'm going to point out two elements on the third energy level of the transition metals. Chromium, which is a weirdo, and copper, which is another weirdo. Okay? So chromium and copper are, what do we call that again? Weirdos. All right, so what happens with chromium and copper? Let's say I'm trying to get to here. Remember, where do we start? Always start at hydrogen. Always start up here. 1s2, we're going to chromium now. So 1s2 gets me across the top row. 2s2 gets me to here. 2p6 gets me to neon. 3s2 gets me to magnesium. 3p6 gets me to argon. My least favorite cookies. 4s2 gets me to here. 3d1, 2, 3, 4. So normally we would think 4s2, 3d4 would be the last line. But it's actually 4s1, 3d5. Okay, so 1, 2, 3, 4, and then one of the 4s electrons comes down to the third d orbital. So chromium ends up with a 4s1 3d5 if it's as its signature line. Copper is exactly the same except it's further along. So this, instead of its last line being 4s2 3d9, it's actually 4s1 3d10. So copper and chromium are weirdos. Everybody else plays by the rules. So that's it. Hope you got some decent use out of this. Remember, ptable.com is the bomb. And hope you have a better time doing electron configurations from now on. Have a good one. I dare you.